All right. Problem number 6. A nutritionist wants to study the effect of storage time, 6, 12, and 18 months, on the amount of vitamin C present in freeze-dried fruit when stored for these lengths of time. The nutritionist is also wondering if different freeze-dried fruit change the amount of vitamin C present. So the nutritionist uses freeze-dried strawberry fruit and freeze-dried blueberries. 6 fruit packages of each, strawberry and blueberry, were randomly assigned to each of the 3 storage times. List the experimental units, the factors, and the treatments. What are the experimental units? What are the things that are being assigned to treatments? The fruit. Specifically, it's the 12 fruit packs. Welcome. All right. The 12 fruit packs are the experimental units because those are the things that will be randomly assigned. The factors. What are the things that are being controlled or manipulated by the experimenter? That is being controlled. The researcher is able to say you only get so much vitamin C and you get a different amount of vitamin C. Storage time. What else? What else is he controlling for here or manipulating? Type of fruit, yes. Storage time. And the type of fruit. Hey, John Lee. So the factors would be the variables that are being controlled by the researcher. You can think of the factors as the explanatory variables. Remember, we talked about that earlier on when we were studying in this module, in this chapter, whatever, that the explanatory variable or variables are called factors. What are the treatments? What are the treatments? Well, everything is freeze-dried. Amount of time that's in storage. So what are the options for amount of time that they're in storage? 6, 12, and 18 months. So there's another difference between these two, though, other than just 6, 12, and 18 months. It's the type of fruit. The amount of vitamin C would be the response variable. That's what we're going to measure at the end. The treatments are the different conditions that these 12 fruit packs are going to be assigned to. So we have 6 months for strawberry. We have 6 months for blueberry. Hey, Brisa. Thank you. What else? 12 months for strawberry. What else? So 6 months strawberry, 6 months blueberry, 12 months strawberry, 12 months blueberry. Yes. 12 months blueberry, 18 months strawberry. And 18 months blueberry. All right. What else would you guys like to see? Number which one? Number 10. Absolutely, we can go look at number 10 next. Which of the following statements is true? Non-response can cause bias in surveys because non-respondents may behave differently than people who respond. Sorry, I lost myself there for a second. Non-response can cause bias in surveys because non-respondents may behave differently than people who respond. Bias arising from undercoverage can be compensated for by increasing sample size. Can we fix undercoverage by getting a bigger sample size? No, because we're still leaving groups out. So we just exacerbate the problem instead of fix it. Stratified random sample is often employed to reduce the impact of response bias. What is response bias? It's not people responding or not, that's non-response bias.
How they respond, why they're responding the way that they are?
Yeah, so like the way the question is worded influences their response, or who is asking the question influences their response. Are either of those things fixed by doing a stratified random sample? No. People's responses to survey questions tend not to be influenced by the age, race, or sex of the interviewer. Wrong, incorrect, that is definitely false. Sophisticated statistical methods can always correct the results if the population you're sampling from is different from the population of interest. For example, due to undercoverage. Can we fix that with fancy statistical methods? No, the only way to fix a bad sample is to get a different sample. So, this is A. Non-response can cause bias in surveys because non-respondents may behave differently than people who respond. What does it mean to say a study is biased? Not necessarily every single time, but it tends to either generally overestimate or generally underestimate the parameter of interest here. So when an error, oops, wrong letter. When an error in sampling or testing systematically skews the results. It's this idea of systematically skewing, like it is either as a whole generally overestimating, so it skews it to the right, or as a whole generally underestimating, so it skews it to the left. But there is this systematic error happening so that almost all, not all, but the majority of my data points are not in line with the true parameter that we're measuring. What else would you guys like to go over? All I'm going to grade is this. Oh. This is all I'm going to grade. All right, I do not need an equation.
Oh, okay.
What else do you guys want to see?
Miss Bull, until one's 5.
Number 5. We can look at number 5. A survey was done in the town of Mechanicsville to estimate the proportion of cars that are red and made by companies based in Japan. A simple random sample of 25 cars from a parking lot at Lee Davis High School was taken. Which of the following statements is correct? Since this is a simple random sample, it should be representative of all the cars in Mechanicsville.
No.
Why not?
Because it's from a parking lot at Lee Davis High School.
Yes, we're only grabbing our sample from the parking lot at Lee Davis High School, so we would only be able to generalize out to the population at Lee Davis High School. We would not be able to generalize out to the whole town because we didn't take the sample from the whole town. If a simple random sample of 15 cars were taken, we would expect the same amount of variability in the proportion of red cars as we would with a sample of 25 cars. Would you expect the same amount of variability if you have a smaller sample size? No. When your sample size changes, the variability will change. When the sample size changes, the variability will change. An alternative method for getting a representative sample would be to select the 25 cars closest to a specified location, such as the entrance to the gymnasium. No, that'd be a convenience sample. We do not want to do stuff that is just convenient for the researcher. We want it to be representative, and that's why we use that random sampling technique. A different team doing the same sampling independently would probably obtain a slightly different answer for their sample proportion. Yes, that one is correct. A different team doing the same thing on a different day, independent of the first group, is going to get something that is probably similar to, but not identical to, the results from the first team. You know, maybe there were 3 people that own red cars that were built in Japan that were absent the day the first group went, but they were present when the second group did it, so their proportions would be a little bit different. And then looking at that last one, the results would be the same regardless of the time of day that the sample is taken. Do you think that you would have the same proportion of red Japanese-made cars in the parking lot at 11 p.m. on a Saturday as you would at noon on a Thursday? No. So that one is definitely false. What else would you guys like to look at? Yes.
So maybe the sample representative of all cars would have to be like in like a public parking lot? Like a,
Yeah, you could use a public parking lot.
like a store, a Walmart parking lot, anybody can go there.
Yes, I would. So if I was actually doing this study, rather than just pick a Walmart parking lot, I would probably pick a couple parking lots and do a random sample of like 10 in those locations or something like that, just so that we get good coverage of the whole town. Yes, I think that would be a better way than this. Yes. Yes. Actually, I got one person ahead of you in line, and then you may go. What else would you guys like to see or talk about? Name, date, and time with the marker, and then the marker goes right back in here. You guys have any other questions for me? Right at noon. Noon on the dot. You all done? Wonderful, thank you.
Mr.
17?
Yeah.
Absolutely. Let's go look at number 17. There we go. As a researcher for a pharmaceutical company, you are designing a study to test the effectiveness of a new treatment for migraine headaches. You have been given a list of 126 people willing to participate in the trial. The first 70 people are female, the remaining 56 are male. The subjects will be randomly assigned to the new medicine or their old current medicine. The study is single blind. What does this mean and why is it important? What does it mean if it's single blind? Yeah, it's, well, to be really, really technical, it's either the participants don't know which group they're in or the researchers don't know which group they're in, but it's only one of those two. In this case, I would make it single blind by having the participants not know. But there's certain other circumstances where if we were trying to test to see the impact of exercise on resting heart rate, right? And I would have 2 groups, one group that exercises and one group that doesn't exercise. The participants are definitely going to know which group they're in. But I could have researchers interacting with them, the people that are measuring their resting heart rate could be in the dark about whether they're in the exercise group or not. So single blind is one of my two groups, either the participants or the researchers are not aware which group the participants are in. So single blind in this case means that the subjects, the patients, will not know whether they are receiving the new medicine or the old medicine. Why is this important? Why would we not want the participants to know which medication they're getting? To reduce bias, specifically how? Yes.
If they know what they'll have, they're gonna assume it works better or something like that.
Yeah, they're going to have expectations. If they know they're getting the old medicine, they're going to expect that they're not going to see any improvement over their normal day-to-day life. You're welcome. If they know they're getting the new medicine, they're going to expect that they feel better. And they might, whether they actually do feel better or not, they might downplay certain symptoms or the severity. Like your brain can play all kinds of tricks and you're like, it doesn't hurt that bad. I think it's a little better than yesterday. Yeah, I think this new medicine is working. Right? And you can like downplay the severity of certain things if you think that something you're doing is making a difference here. Demiri. Right, write your name, date, and time on the pass, and then put this marker back in this caddy right there. So it's important so that subjects and patients' expectations do not skew the results. Same could be said about if the researchers are the ones that are blind. We don't want the researchers' expectations to influence results either. Preliminary research suggests that men and women respond differently to this new treatment. What sort of experimental design would you choose for this study and why?
Matched pairs.
We could do matched pairs. I don't know if that's the best design for this one.
Stratified.
Stratified is not an experimental design, but I like where you're thinking. It feels like stratified, but it's called by a different name. Block. Blocking. A randomized block design should be used. You could absolutely make a believable argument that I would accept for why matched pairs would be better here. But you would have to explain to me why you're picking that one. I think a block design, since we think that gender has some influence over reaction to drugs, or you could think of it more like biological sex has something to do with people's reactions to these medications, I would want to control for that variable. Matched pairs allows for a higher level of control, which makes it a little bit more complicated to pull off, but I could match. It'd be a little bit harder, but you could talk about, like, I could take the two women with the most severe symptoms and match them together. And then the next two women with the next most severe symptoms, and so on and so forth. But I want to make sure to match women to women and men to men, because I think that gender has something to do with this. All right, so randomized block design. Blocking by gender reduces the variability in the response variable. Blocking by gender reduces variability in the response variable, which would be migraine severity or frequency. From the differences between the responses of men and women to the treatment. A completely randomized design would have more variability. Yes. Give me just a second. So, in some respects, that's a little bit of a difficult question to answer because it depends on the type of question being asked. But usually what I'm looking for is, did you hit on the key important features that they tend to talk about in the FRQs, in the grading notes, the rubrics that are used to grade student work with? Because I'm either using FRQs from the past on the test, or I'm grabbing questions that are very similar to, just a couple things changed from the FRQs. So I can go back and look at, in the scoring guidelines, what they felt were the most important components to get full credit for that, and those are the things that I'm looking for. So that's the short answer. All right. Part C. Explain why an experiment involving 70 women and 56 men is preferable to one involving 10 women and 8 men. Why is it better that we've got 70 women and 56 men rather than a much easier to handle 10 women and 8 men?
The effect of confounding variables.
Basically, it's going to reduce the impact of random variation in the results. So those confounding variables that could be present, we want more people because now I've got things like more randomized, right? I could end up with a smaller group. I could end up with 10 women that all have really severe migraines and 8 women or 8 men that have mild to moderate migraines. And then even with blocking, I'm going to have a hard time telling whether it's the medication or whether it was the initial severity. But with larger groups, I'm more likely to get men that experience severe and chronic migraines, men that experience moderate and mild migraines, men that experience not as many migraines, very light. I can get all of these different things in my 2 treatment groups with a larger sample or with a larger experimental group. So I would say a larger number of subjects in this case, these subjects are patients. We want replication here. Reduces the impact of random variation on the results. This increases our ability Thank you. This increases our ability to distinguish the effects of the treatment. Right. D, describe a design for this experiment and be sure to include a description of how you assign individuals to the treatment groups. And then this last sentence change that is different from last year. Just describing it using like paragraph or bullet points, how we're going to do this. So we said we want a randomized block design. So the first thing I'm going to do is divide the 126 volunteers into 2 blocks, 70 women and 56 men. All right, so now I have these 2 blocks. What do I want to do with those 2 blocks? What's going to end up happening to all the people? They're going to get labeled, randomly selected and assigned to a group. So we're going to describe this process for one of my blocks, and then we will repeat the process for the other block. There's already a calculator in the back. Yep. So I would say for the 70 women, label each person with a unique number from 1 to 70. All right, after I have them labeled from 1 to 70, what do? Assign them. Randomly select 35 women. How are we going to randomly select them? With an RNG. Use an RNG to randomly select how many? 35 women, or 35 numbers, sorry, 35 numbers. Unique, yes, thank you. 35 unique numbers between 1 and 70. Okay, once I have those 35 unique numbers, what are we going to do? To the new migraine medicine. So we're going to randomly assign 35 numbers to a new migraine medicine. Hold on. Hold on. What'd you say? Assign 35 people, but I don't have 35 people. I have 35 numbers. There we go. We need to match the corresponding people to the selected numbers and then assign those people to receive the new medication. Assign the women with the corresponding numbers to receive the new medicine. So what about the other 35 women? Yes, assign the remaining women to receive the old medicine. Cool. So now we have 35 people getting the new medicine and 35 people getting the old medicine. Then what?
Repeat the same process for the 56 men.
Yes. Repeat this process to assign the 56 men to the 2 treatment groups. How many should be in each group? 28. 28 to each treatment. Okay, so we described in detail what we're going to do for the women. For the men, we can get away with saying, do that again, but for this group. And now what? Because we were supposed to design the whole experiment here.
At the conclusion of the experiment,
Yes.
see the effect of the medicine.
At the conclusion of the experiment,
Test the effectiveness of the.
I'm going to compare the results. That will allow me to see the effectiveness, but we're going to compare the results at the end. I'm going to say within each block. So I want to compare women that had the new medicine to women that had the old medicine. And then I want to compare men that had the new medicine to men that had the old medicine so that I can see, is there a difference between the way the men responded versus the women? Then combine and compare. I don't have a lot of room to write that, but basically, after I compare women to women and men to men, I'll take all the people, men and women, that got the new medicine, and all the people, men and women, that got the old medicine, and I'll compare new medicine to old medicine for the whole experiment. So women get compared to women, men get compared to men, and then everybody that got new gets compared to everybody that got old. Does that make sense? Cool beans. There is one last teeny tiny piece of this question. Part E. Suppose we created a third group to assign to a placebo medicine instead of the new or current medicine. Describe the data ethics for this scenario. So this isn't really something that we went into, but I want you to think about this for a minute in context. You suffer from migraines. Your migraine medication works okay-ish, but there's a new one coming out and your doctor has recommended you for this trial because he's not quite sure this old medicine is working for you. So you sign up to be part of this trial and you either randomly get assigned the new medicine, hopefully it works. We're fairly confident from preliminary data that this works, at least as well as the old medicine. We have the old medicine group.
Oh, sorry.
That's okay, thank you. We have the old medicine group where you're not really going to be facing any changes or any differences in what you've been experiencing already. Or you get the placebo. What happens if you get the placebo?
You think that you're getting the new medicine,
You think that you're getting the new medicine,
but you're not.
but you're not. I want you to think about this from the perspective of somebody that's actually taking medicine for a real problem that causes pain. If you all of a sudden stop taking a medicine that has any active ingredients in it whatsoever, you're taking a sugar pill.
It's gonna get worse.
It's going to get worse. Your life is going to be demonstrably worse because you are going to be in pain. Like you're pretty much guaranteed to be in pain. Old medicine, it's at least somewhat controlled. New medicine, hopefully it's even better controlled. Worst case scenario, it's the same as the old medicine, right? But if you go off of everything entirely, you are going to be in pain for the duration of this experiment. Is that ethical?
Wouldn't the placebo be the old medicine? Just you think you're taking the new medicine, but you're actually taking.
So a true placebo. Now, our old medicine group would be our control group. The placebo is a treatment that has no active ingredients whatsoever. So the old medicine is not a placebo because it has active ingredients in it. It is doing something. It is changing their body chemistry.
What's the point of taking a placebo in this test? Because if they're already single blind, they don't even know what they're taking.
Correct.
So what, aside from getting worse, what else would you get from this?
You're going to get people in pain is what you're going to get.
But my assumption, if you're comparing the two medicines on how much more effective the new medicine is, why would you give them no medicine?
That's the question. That's the question.
Like that.
Describe the data ethics for giving someone a treatment that doesn't contain any active ingredients in it whatsoever.
You're not allowed to do something like help in pain.
Yeah.
It's in psychology.
Exactly.
That's one of the ethics you have to do. You're not allowed to cause pain or discomfort.
You're not allowed to do things that will make someone's life worse, knowingly. It might accidentally make their life worse, but that was not your intention, and you did not know that ahead of time, right? Somebody can always have a reaction to medication. In that case, their life wouldn't be getting better, but you did not intend that. You did not go into it knowing, hey, your life is about to get worse now, right? That would be horrible. This would not be ethical because all the participants are known to be migraine sufferers. To give them a placebo would mean withholding necessary medicine and could cause harm to the subjects or the patients. Absolutely not okay. Right. Yes. What restroom? Yes. Has stuff like this occurred in real life? Yes. Stuff like this has occurred in real life. There was a study done a while ago, a long while ago at this point, with a group of people that they knew these people had an illness. And there was a cure for this illness that was withheld from the people that were sick. Because they wanted to see what are the stages of this disease, with the end result being death. So they withheld the treatment, knowing what they had, they withheld the treatment because they wanted to see what are the stages of the progression of this disease. That is completely unethical. And yes, that really did happen. I'm not going to get into the finer points of this particular one. If you study psychology, they talk about some of these experiments.
What is it?
That's what we do.
Why? Why? I wish I could use
I will go far enough to say it's an STI.
That's cruel.
Yeah.
It's an STI. And they withheld treatment for one that is curable.
Is it a popular one? Wait, that's
Popular.
No.
That is not the right word to use here.
A common one. Is it a common?
Yes. Yes, it's a common one.
Yeah, it's
All right.
popular.
If it's this.
Yes. What else did you guys want to look at or talk about? What else do you guys want to look at or talk about? Yes. 7. We already did 6. We already did 6. A researcher observes that on average, the number of divorces in cities with Major League Baseball teams is larger than in cities without Major League Baseball teams. Which of the following is the most plausible explanation for this observed association? The presence of a Major League Baseball team causes the number of divorces to rise. Is that a reasonable explanation? Why not? They didn't do an experiment. We didn't randomly assign cities, right? The high number of divorces is responsible for the presence of Major League Baseball teams. This right here is another way of saying causes. If something is responsible for something else, it is the cause. Do you think the high number of divorces causes Major League Baseball teams to move into town? No. The association is due to confounding. Major league teams tend to be in large cities with more people, hence a greater number of divorces. That's possible. Let's put a question mark next to it and keep reading. The association makes no sense, since many married couples go to the ballpark together. Yeah, I'm going to go with no on that one. The association is purely coincidental. It is implausible to believe the observed association could be anything other than accidental.
Absolutely.
So I think it's C.
I think this is C. I'm going to go with C. If you have a large city, they can financially support a baseball team because you need lots of people to come to the games to support this, right? So high.
Why would it not be E?
So what we're looking at here with C, the confounding variable would be the size of the city. The size of the city is what would be causing these Major League Baseball teams to want to come there, right? They're probably not going to choose to put a Major League Baseball team in Muncie, Indiana, right? We don't even have one in Indianapolis. However, between the two, which one has a better chance of getting an MLB team? Indianapolis. It's a larger city. The population can support that type of expense. We have enough infrastructure that people from out of town could come in to go to the games. They could stay in hotels. They can eat out at the restaurants. Muncie is not big enough to support an influx of people that would want to be going to an MLB-style game.
We have Victory Field right next to Marion.
Yes.
I feel like we could get a major league team. I feel like now
We
that
are,
the
but-
we have a minor.
In the 11. In the 11's coming.
No.
In 11 is
for
soccer.
baseball.
Well, yeah, but then we
We could have an
Yes.
MLB. We could have an MLB team because we have coaches.
Right. We have lots of professional teams here.
Yeah, I'm saying we could have one. We just only have a minor league.
Yes. So if you were to compare just straight numbers, number of divorces that happen in Muncie versus number of divorces that happen in Indianapolis, which one do you think is going to be higher? Indianapolis, because there's just more people here. So that's what part C is saying here. We have a bigger city, so just by like law of large numbers, we're going to have more divorces here just because there are more people here who could potentially get divorced. The larger city can support the infrastructure that is going to attract and draw these major league teams. So this association that we're seeing here is the result of confounding, not just coincidental. If it was just coincidental, then the size of the city would have nothing to do with whether or not there's a Major League Baseball team. What else would you guys like to look at? What else would you guys like to look at? Are there any other problems that you guys would like to go over? Number 8? Sure. Control groups are used in experiments in order to accomplish which one of the following? Limit the effects of variables other than the explanatory variable on the outcome. Control the subjects of a study to ensure that all participate equally. Guarantee that someone other than the investigators who have a vested interest in the outcome controls how the experiment is conducted. Achieve a proper and uniform level of randomization, or reduce the variability in results. What do you guys think this one is? I heard not B. Okay, let's go ahead and mark that one out. This is not to control the subjects to make sure that they all participate equally. Somebody that's not going to participate a lot, we want just as many of those people in the treatment group as in the control group. A. I like A. Limit the effects of variables other than the explanatory variable on the outcome. What about E? Reduce variability in results. So blocking and matched pairs will reduce variability, but having a control group is just one aspect of a randomized experiment. What else would you guys like to look at? Nothing? All right. Any other questions? Any other questions? All right. Multiple choice practice is your assignment for tomorrow. You have to go through Canvas to get there. It is linked in Canvas, but additionally you have to go through Canvas so that you get marked as present for the day. You need to do this sometime between like 12:01 a.m. and 11:59 p.m. Do not get in and do it early or you'll still be counted absent for tomorrow. All right? 12:01 a.m. is when it opens. 11:59 p.m. is when it closes. As long as you log in and do the activity sometime between midnight tonight and midnight tomorrow, you will get counted as being present for that school day. All right?